Okay, so what we're looking at today is we're going to look at the normal distribution. Okay, now this is the sort of question you're going to get in the test. All right, so I'm going to just read it out to you in case you can't read it. Okay, a manufacturer of hard drives knows from past records that the failure rate of drives is normally distributed with a mean of 42,000 hours and a standard deviation of 7,000 hours. Find the probability that a hard drive selected at random from the manufacturer fails before 30,000 hours. So that's going to be the basic question. You've got to work that out. Okay? And so the way we're going to do that is we're just going to go through some basic ideas and then we'll come back to that question. Okay? So this is a normal distribution. Okay? It has a mean and a standard deviation. Now, a couple of other things we've already established. It's bell-shaped. Okay? It has tails. It has a single mode, and it's symmetrical. Okay, so it has tails going out top and bottom. Okay, it's symmetrical about the mean, so the mean is smack bang in the middle. Now I'm not a great drawer, so this picture doesn't look very symmetrical. It looks skewed to the left. Okay, but that's just because I'm a rubbish drawer. Okay, it's got a single mode. There's the mode at the top. It doesn't go up, down, up again. Okay, and it's bell-shaped. Now we look at a perfect standard normal distribution. So we look at this idea that we have our curve, which looks like this. Now this one has got a small standard deviation. In other words, it's not very spread out. This one is going to have a large standard deviation. And that's what we're talking about. So the standard deviation decides how spread out the whole thing is. So a tiny standard deviation would look like this. But can you see all three of these are still bell-shaped? They have tails, they've got a single mode, and they're symmetrical. Okay, so they're all normal distributions. Okay, so how far spread out they are is determined by the standard deviation, and where the centre is determined by the mean. Okay? And for the next 5 minutes or so, we're going to be looking only at this idea of the fact that let's pretend that the mean is 0. So for instance, if we were doing something where you had to hit a target, and we measured how far away from the target you got, on average you got 0. So sometimes you're too far, plus numbers, sometimes you're too short, minus numbers. Okay, so we're going to imagine we've got this particular world. Okay, so we're going to draw our curve like this. There we go. And I'm going to say that the mean is 0 and the standard deviation is 1. And that's the perfect one. We can exactly work out everything that goes with that one really easily. Okay, so I can say that between +1 and -1, which I would normally write down on the scale at the bottom, so there's 1 and there's -1, we can say that that is approximately 68%. Now when I said to you, how about probabilities? If I then said to you, if the mean was 0 and the standard deviation was 1, what's the probability that you get between 1 and -1? You could say it's about 68%. Okay? But there's some other things we could say immediately about that. How about if I said to you, what's the probability of getting a value between 0 and 1? Well, I've told you already between -1 and +1 there's 68%. And I've also told you that it's a normal distribution, which means that it is symmetrical, which means that this bit here must be the same as that bit there. So the probability of between 0 and 1 is approximately 64%. Sorry, big one, try that again, 34%. Does that make sense? Because it's symmetrical. How about what's the probability then that it is x is going to be greater than 1. Well, it's not 34% because this is where we need to get the understanding of the thing. So the first rule of solving the problems is draw the picture. That's the very first rule. And that's all we're going to be doing in this first video, is drawing the picture. Okay? So I want the probability that it's greater than 1. So here I go. I draw my picture. I just draw it freehand. I'm not too worried about it getting it absolutely perfectly. That little dotted line there, what's that number? What have I already told you that number is? 0. Excellent. Good. I want 1. So I put a little mark 1 and go up like this. Okay? Now, I asked for bigger than 1. So which bit to the picture am I going to colour in? This end here. Because those people in that area there are bigger than 1. Does that make sense?
Yep.
Okay? Now, I already know that this spot here is 0.34 or 34%. I already know that bit, don't I? I also know that the whole thing's symmetrical, which means I know that all of this bit here is 0.5 because it must be half of it. So is it really obvious to you that this bit here must be 0.16? Because 0.34 plus 0.16 makes 0.5. Okay? But we need to understand the fact that the only thing you will ever be able to work out is this bit here. This is the bit you ever work out. You can't work that one out using our system, but we can work that out. And because we know that, we can work that out from it. Does that make sense? So let's do a couple more of those, shall we? So all I want to know is, is this. What happens, what's the probability then of getting a number x is less than or equal to 1? What's the first thing we need to do? Draw the picture. So we draw the picture. So we just draw ourselves a picture. There it is. Little dotted line down there. There's the number 1. That's the number 0. Standard deviation is 1. We know that. So less than 1. What's that? Well, is that not from 1 downwards? So can we just colour in that and all of that? That's the picture of less than 1, isn't it? Does that make sense? Now, hang on a minute though. I know that this bit in here is 0.34. We've already established that, haven't we? What's this bit here? This bit here is half of it, so that's 0.5. Remember, it's symmetrical. So remember the 0 line is halfway between the two, isn't it? Yeah, so this bit here must be 0.5, this bit here must be 0.34. That's the bit we're going to work out. So therefore the answer is 0.84 because I've just added those two together. Am I making sense? Okay, so what about the probability then that x is less than or equal to -1? What do we do first? We draw the picture. If you get in the habit of drawing the picture every time, you will have no trouble with normal distributions. What's that number there? 0. Okay. Here's the number -1. I want less than -1. What am I going to colour in? This bit here. Everything to the left of -1. Okay. Now what's the only thing I'm able to work out? I can work out +1. I know that that bit is 0.34. Remember that it is symmetrical. So if this bit's 0.34, how big is this bit? Is 0.34. So if this bit's 0.34 and that bit's also 0.34 and this half is half, then what you end up with is 0.5 take away 0.34, so this bit's also 0.16 like it was earlier. Am I making lots of sense? Okay. How about, what's the probability that it is that x, sorry, beg your pardon, that negative 1 is less than x, no, other way around, is bigger than x, but also at the same time, I'm going to scrub that out because that's terrible. What happens if it's not between negative 1 and positive 1? Let's write it that way. Let's write it in plain English. I can do that, by the way. If you're worried about the symbols, write it in straight English. I was suddenly getting all confused as to how to do the symbols, so I just wrote it the right way. Well, how are we going to colour that in? What do we do first? We draw the picture. So here we go. We draw the picture. What's that number? 0. Here is negative 1. Here is positive 1. Which bit am I going to colour in this time? I'm going to colour in the outsides. That's exactly right. Thank you. Right? I'm going to colour in that bit and that bit, because those are the bits that are not between 0 and 1 and negative 1. Okay? Well, what do we know about this bit here? We know it's 0.34, don't we? What do we know about this bit here? It's symmetrical, so therefore it must also be 0.34. Okay? Now, what do we know about the whole thing? Well, if this half is half, and this half is the other half, then the whole thing must be 1, yeah? So therefore, the answer to my question is 1, take away 0.34, take away another 0.34, which is obviously 0.32. You can use your calculator, it's fine. Okay? And that's the introduction to the concept of the normal distribution solution.